Okay, we're reviewing for the final, and the topic is word problems from Exam 1 through Exam 3 material. The half-life of radium-226 is 1,590 years. A sample has a mass of 100 milligrams. Find the formula that represents the mass of the sample after T years. So one thing we need to remember is that for half-life, when we're trying to have a model that represents the mass after so many years, but the general form is y of t is equal to y of 0 for y naught, not this y naught, but y of 0, e to the kt. So we're just going to write this a little bit more specifically. It's implied that the initial amount, or y of 0, is 100. So that's easy. The thing that we need to figure out is k. K is specific to each element in its half-life. So we're given the information we need to find k. What we're going to do is we don't know what the amount is at some later time, but we know that half of the initial amount, so for y of t I can put half of the initial amount, and then the initial amount on the other side, because that's part of the equation, times e to the k, and that time for which that occurs is 1,590 years, that will be the amount left as half of the initial amount for when t equals 1,590 years. So when I do this, I could put y of 0 is equal to 100 to be more specific, but it's actually not necessary, because what I can do, y of 0 is just a value, and I'm just going to do it this way in general so that if it weren't given, you could still do this problem. I divide by it and it goes away. So 1/2 is equal to e to the 1,590k. Now we're going to do some log algebra. Take the natural log of 1/2. Take the natural log of the right-hand side. And that was the reason we're doing this, because the natural log of e to the something just reduces down to that exponent, 1,590k. So now it's very easy to solve for k. I just divide by 1,590. And remember in your book they get fancy here and do some algebra. And what I told you guys is to not worry about that and just find approximately what the natural log of 1/2 is over this value, in this case 1,590, and that'll be good enough. So what we get in this case is -0, well, I'll write it the whole thing, I guess. Natural log of 1/2 is about -0.69315 over 1,590 is about -0.000436. So all that's left to do is go back and write our model with the initial amount in there, with our k, -0.000436 times t, and we'll call it a day.